And then I moved to Twitter, where we built another tracing system based on Zipkin called Pintrace at Pinterest. And at Pinterest is one of the first, like the first open tracing library was happened at Pinterest actually. Like the spec came out of the library I wrote at Pinterest. Unfortunately, that's not the open source one, but that's where like a lot of ideas for that spec came from. Well, there are ideas existing, but that's where like that's where the rubber meets the road. So we kind of validated what works and what doesn't. Then I also worked on like the metrics infrastructure at Twitter. I worked on OpenTSDB, the open source database, time series database. I worked on, so at Slack, we run Prometheus. I'm very familiar with that. I even wrote like an in-memory OpenTSDB compatible metric storage engine called UV. That's also open source. It's on Pinterest repo. But in general, other than like, while I focus on observability now, in general, I'm like super passionate about like distributed systems and like infrastructure. Before Pinterest, I worked on like my first job, like I worked at Yahoo, I worked at Goldman Sachs in India, but in US, I worked on like EC2 before EC2 was actually like well known. Like it was like 100 people back then. So I built like the VPC layer of EC2. And then I worked at Facebook afterwards on Hack, HHVM. And then at Twitter, my initial project was Apache Mesos and Apache Aurora. And then I was the front-end lead for that. And then I started like moving into observability at Twitter and has worked on observability since. So that's about me. Going to tracing 101. So like if you have like even a simple system or like a complex set of microservices, right? One of your biggest problems is like it is slow is like the hardest problem to debug in a distributed system, right? Like it can be slow for several reasons, right? For example, let's say IBM is a customer for Slack, right? And they are like one of the largest customers. And what happens is a slow request is only slow for IBM, but not for others. So like when you're looking at P99s or something, it doesn't show up, right? But it's consistently slow for IBM, right? So we want to know like why is it slow? It can be slow because we may be doing like more calls for an IBM request, right? Or we may be making calls, the same number of calls, but each call may be taking longer, right? Or it may be just be a slow connection issue, right? Like IBM's network may be bad, or IBM to AWS may be bad, right? Or maybe all IBM, like the IBM employees who are seeing slow connections are on like 3G phones or something, or 3G networks, right? And we don't know, like, and to fix a performance issue, you have to first narrow down like which of these is a problem, right? And then fix the problem, right? If you can fix it. So what do we use? We use like dashboards, right? Like we usually use metrics or logs, right? So what are metrics? Metrics provide an aggregated view of performance about a service, right? They provide like counters about how many requests am I getting, how many errors am I getting, and so on, right? Whereas logs provide fine-grained detail about like request execution, right? The problem with debugging using metrics is it does not have information about how a single request executed, right? The problem with debugging with a log is you know like how some specific thing happened, but you don't know what happened before it, what happened after it, or what happened with it, or something like that, right? You don't have that context. So what happens is you have to like manually take these log messages from like these several services and manually correlate them, right? So when like a customer complains, you take their logs from their mobile phone, you take their logs from like backend service and like all the backend services that are part of this call, and you're trying to do this like tie these logs together to see where the slowness of a request is coming from, right? So most of the time to debug these, right, what are we doing? We are trying to get logs from a bunch of places and then tying them together to see where the latency is coming from, right? So like it's kind of like wasteful for humans to do this over and over again, right? So wouldn't it be great if like computers can actually like stitch those logs for us and like just give us that that path of like how a request went, right? So that basically is what a trace is. A trace is nothing but it's logs but it has causality, right? So what it has is you'll have a parent-child relationship between an event that happened before you and an event that happened after you. And it also captures duration. So what you can do is you can take those things and then you can actually present a trace like you see in the slide here, where you can actually see that, let me point to it. So this is like a top level span, like this is the request that we get, right? That request gets, like we call it, we make a bunch of memcache calls, right? So this is a request for chat.post message. That's the API. Whenever you use Slack and you send a message, that is the trace for a single message sent in Slack, right? So you can see like we do some rate limit checks, we hit memcache a bunch of times, we hit MySQL, and then we actually make like a bunch of gRPC calls. That part is not in the trace, right? So this is basically what traces are, right? So it gives you like a unique view of like it gives you correlated logs of along a request path, right? So what happens is most of the time people will say, hey, like I have this problem of correlating logs. Traces are like an awesome solution for this, right? And once I build a tracing pipeline like this, right? So this is the tracing pipeline we built at Pinterest. What does it do? Like you have applications at the top, right? And then all these applications write the data to a trace processing backend, which is like the lower part of the graph image. And in the lower part, you can see like we write the data to Kafka, and then we have a Spark job. It basically does some bunch of pre-processing on the spans and then writes it to Elasticsearch Zipkin. And then we use a Zipkin UI, open source Zipkin UI, to basically view those traces, right? So we basically, this is like the story of tracing anywhere you go. You have this problem, you figure out tracing is what the solution is, and then you build this pipeline to trace your request, right? But that's the end, right? So it's like happily ever after, right? That's but that's actually not what happens, right? There are like a bunch of probable endings. One of the probable endings is basically people are not happy with tracing, and in the end they just decide it's not worth the effort, and then we don't want tracing, right? Like you build it, but people just say it's not useful for us, and then they move on to like going back to the logs and right. Or other ending is, hey, like we have this tracing thing. It's like sometimes useful, but it's just too much work, and we don't want to like put in any additional effort. So initially, like somebody spends like 6 months building it, and then afterwards, like it's not enough ROI, and then just falls by the wayside, and nobody cares about tracing anymore, right? This is basically the story even in like large companies, like even at companies that invented tracing like Google, right? Even companies that invented tracing like Twitter and like Uber and all these companies. This is kind of like the general sense, which is, yeah, it's cool, but you know what? It's like the amount of effort involved and like the value again is like not very high, right? And the reality is like, hey, the reality is like, hey, it's not like I'm crazy about this thing. It's complicated, and people just have these mixed feelings, right? Like they cannot live with it, they can live without it. It's complicated, right? So like having built these systems, right? Like Twitter and like Pinterest and like they're like basically like 5 to 10 like large tracing systems in the world, right? Like and like I built like 3 of them, and one of the things I figured out is um, like one of the learnings I had is that there are a bunch of problems with tracing that like as a tech lead of Zipkin, like I made a lot of those decisions, and like in practice you'll see that those decisions are actually bad, right? They're not very fruitful. What actually ends up happening is because it's complicated, we decide like when I came to Slack and we wanted to do tracing, I said, okay, we want to do something different. So we don't end up in like any of these 3 probable endings or the realities, right? We wanted to make it successful. So this is where like we made this leap to like causal graphs, right? But the question is, why did we end up in this like it's complicated situation, even in the best case scenario, right? Why is it not a wild success? So there are like a lot of reasons, but I'll give like top 3, right? That'll be like the big 3. So the first reason is every time you install Zipkin or Jaeger or like even vendor tools, the trace UIs are like super limited, right? In the sense that you can like put in like a bunch of query and then you'll get a trace that matches that query and you can click on those traces, right? So that's good. But the problem is, once you have sampling and once you have like a complicated question, the first thing that happens is you like your question is complex enough so that you can put the right parameters in the trace UI to figure out the right trace, right? So what people end up doing is they go to their metrics, they go to their logs or something, and look up like some interesting trace IDs from their logs, and then come and like put a trace ID in Zipkin UI, right? But you can't search for that, like you can't ask that question in Zipkin UI, and in the logs too, it's like a hit or a miss. So the thing is, to use a trace UI, you need a lot of expert intuition to get the right trace. And that is the hardest problem, right? And that expert and the expert intuition is it needs to be good enough that if you actually had that good of an intuition, sometimes you may not even need its trace. You can actually use the other tools, right? Uh, so that's the big problem. So why do you need like this? Why is it so hard to find like these representative traces? The biggest problem is we can't mix and match span data across different places. Like for example, you have two spans in a trace or two spans across traces. You can't like mix and match the data. You can't take a span from here and say, hey, like show me all the traces where the other span was also like this or something like a complicated question like that. You can't ask or answer, right? So that is one of the problems. The second problem with trace view is it actually shows you that I showed you that like graph, right? Generally, it is very easy if there is like one thing that took like super long from that view to say that, hey, like this is the thing that took super long, right? But in practice, yeah, there are like in some cases there are like those things where it's very obvious, but there are also things where it's not very obvious why something is taking a long time, right? It may be like a lot of small calls. Each individual call may be fast, but unless you look at a different trace, let's say I can take an IBM trace where I'm making a lot of small calls, right? And I can take like a 10% company trace, and there maybe I only be making two calls, right? But without knowing that I'm only making two calls in that case, but I'm making like 10,000 calls in this case, just looking at a trace, I won't know why it is slow, right? So this is why like trace view doesn't really tell you what is slow. Again, you need expert intuition to read the trace data to know like why it is slow. You need to know the code, you need to know your architecture, you need to have some intuition about how things work, right? And then as a result, right, like because of like limitations of UI, how you can access the data, excuse me, and the trace view, like the learning curve for like using trace data is like pretty steep. So the second thing is people go to these demos and they probably see a tool on top of trace data, or they see like a service graph view and things like that. Right? Zipkin has one, Jaeger has one. Like they look really cool in demos, but turns out in practice they're like absolutely like not useful at all. Like in practice, when you're looking at these like crazy view, it's like it kind of is like overwhelming and like awesome to look at, but when you actually want to ask any questions, it's actually not useful at all. So that's the other problem. Like those are the problems with like UI and visualization, because they provide you one view into your trace data, right? And that view may be like useful, may not be useful. If it's useful, good, tracing is useful. If it's not useful, then trace data is not useful at all, right? So what we want to do to solve that problem is, instead of providing like different views and like different query languages, what we want to say is, hey, why you already access your logs and metrics as raw data, right? Like you have the raw data and you're just like constructing a query on it. Why does trace data need for accessing trace data? Why do you need to do like use a fixed UI, right? Why can't I query raw trace data, right? If you could query raw trace data, right? Let's say using SQL or a different query language, you could formulate a query for the problem you're having and not have to rely on someone building a very opinionated tool or providing an opinionated view, right? So this is the first lesson, which is if you can query raw trace data, the trace data is very rich. you can actually get more powerful answers from the data, right? That is the first intuition we had, right? Now, that kind of is like the first intuition. Now, okay, why can't I query raw trace data? Turns out the biggest problem of like querying raw trace data is like spans are not databaseable, right? So what it means is if you take like a Zipkin or Jaeger span format, the span formats are like have a lot of deep nested structures in them. But if you look at a database table, right, it's like flat. It doesn't like SQL or databases don't like nested structures, right? And you like the language doesn't provide you an ability to like query nested structures or anything like that. And also, once you add nested structures, people will do all kinds of like crazy things with it, right? So because spans are not databaseable, uh, you don't want like those nested structures, right? Now, why do these nested structures exist, right? Like if you go to like a Zipkin span format, uh, right? We can see. Let me just do that. Um, this, yeah. So if you go to a Zipkin span format, right? If you look at it, it has like okay trace ID, right? It has a parent ID. It has an ID. Okay, reasonable, right? Then there is like something called a kind, right? This description, like obviously there is a lot of helpful description, but this kind thing is actually an internal detail of like how Zipkin thinks about spans, right? This is not exposed to the programmer. Your Brave library or whatever library you're using to report your spans knows about it, but your UI also knows about it, but you don't know about it, right? Then there is a name that's useful. There's a timestamp and duration that's useful. Then there is like endpoint, right? Endpoint is like a network centric thing, right? Like endpoint is only there if you're making a network request, right? If you're not making a network request, endpoint does not make sense, right? And then this is where like the nested things come in. Like you have this annotations, like a list of annotations, which is a nested structure, right? Like now the question is like what is an annotation, right? An annotation is basically if you have a span that represents something happened. An annotation is something happened in between that duration, right? It's like a it's like an event that happened during that duration, right? That's an annotation. Now the problem with that is you can also create a child span saying the same thing, right? Why create a annotation for that, right? That's one of the ideas. So like things like that. The reason and this makes like spans not databaseable, right? And then you have tags. So tags is reasonable, right? Then there are like debug and shared. I'm like, okay, why do I need this, right? So the thing is, if you're trying to, let's say, put this in a database table, even by removing the nested structures, there's a lot of information in a span that is kind of confusing for a novice engineer or for like a even for advanced engineer, it's kind of like confusing, right? So what we actually do is, and then there are like these other things like list of spans is like a list of spans. Okay, why do I need this? It's like an API thing, right? And if you notice, a span, I don't think has a service name here. Does it have a service name? Um, Yeah, this is the other thing. Like a span does not have a service name here. Like the service name is actually added as a tag, right? So it is kind of confusing, like which service the span belongs to, right? So the point is, there are like a lot of details in like the SpanEvent format that make it not friendly for developers to directly consume, right? If I put them in a database, and SQL is not powerful enough to like query those features, right? And the other thing is there is a shared flag that I showed you earlier, right? The shared flag is basically Zipkin has this notion of single host spans and like shared multi-host spans. What this means is you can have a span where half of the data in the span comes from the client and half of the data comes from the server, that proved like too complicated. This is like a kind of an artifact from like the Dapper paper, right? But what happened over a period of time is people said, hey, like single host is better. So, which is basically what Jaeger's like, one of the reasons Jaeger was written is because they kind of found a single host, multi host thing to be harder to use in practice. So they did Jaeger, which only has single host spans. And then once it was proved to be a simple model, even Zipkin moved over to the single host spans model. But for backwards compatibility, they keep that shade field to actually represent the shared information. And that is also the reason why it also has, like, this is also why a span is network centric, because they were designed for client server communication, right? To represent both sides of the client server communication, right? And then if you go to the Jaeger format or like open trace, open sensors or something like that, or even like open telemetry, you would see like these two fields called tags, and then there is another field called logs, right? This is like how the data is stored, right? Logs are longer strings and tags are shorter strings, right? But if you give them to a developer, he doesn't know, right? People will put a long string in a tag or like a shorter string in a log, and then they won't know, right? So there are like problems like this. And then the trace ID is generally split between two fields. Like in Jaeger, for example, there's like it's a, if you have a 128-bit ID, there is like a high 64-bit long and low 64-bit long where it's split, right? If you again expose this to the developer, they're confused, right? Like developers are already overwhelmed with like how their application works and like all the context, right? Now, if you add to that this additional burden of like thinking about like span formats and things like that, like they already are thinking about database tables for their application, they're thinking about like data structures in their code, right? This will be like a third thing that is actually tangential for them to think about, and it just is like too much information to keep in anyone's head at any point, one point, right? And the other thing is, there are just too many span formats. Every open source project has its own span format, every vendor has their own span format, like not like they are kind of similar but not really, right? So that's the other problem with span formats, right? In addition to them being hard to use, it depends on like what version of Zipkin you're using. If you use an old version, the span format is different. If you use a new version, it's different. Jaeger, same thing. You go from Jaeger to Zipkin, the span formats are different. You go to like Jaeger to Haystack, different. Jaeger to X-ray, different. Jaeger to Lightstep, different. Like everything is different, right? Because everybody's just because it's an internal format, nobody tried to standardize it until open telemetry. And even open telemetry spans suffer basically because they were like just they took like this thing and then ported over there. They also have the same problems, right? So what we did is we created a simplified span format called a SpanEvent format, right? The idea of a SpanEvent format is basically like if you forget everything from the stock, like one thing to remember about SpanEvent is it's span minus annotations. Like that's the SpanEvent format. We didn't like invent anything new. We just simplified it. So it has like the same fields I showed before. It has an ID, it has a parent ID, and it has a trace ID, right? In addition, it also has a timestamp and a duration. So the instead of like a so some span formats have like a timestamp, which is the start time, and an end time. So what happens is when you're trying to query it in a database, every time, most of the time, duration is more important than end time, right? So what you have to do is always like do start time and end time, which is like very slow. So what we actually do is we do timestamp and duration and not end time. So that way, most of the your queries can actually happen in a duration field, right? Then you have a name, then you have a service name. Like we called it like name and type here, but it's like name and service name. And then you have a set of tags. So the thing with R tags is the Zipkin tags are like string, right? R tags are actually string and like value. The value, the reason we do a value type is because we want to preserve the type of the field. So when we actually store it in the database, we can do more efficient storage, right? If you just do it as strings, like you lose all the benefits of like storing the type in a database, right? And then we also have like a special field called like span type, which we just add to the tag, and then it shows like the type of the span instead of like this kind tag or something like that. So okay, so now we have a simplified span event that is easy to query, right? Now, what is the third problem? The third problem turns out is uh, traces are not just hard to consume, they're also hard to produce, right? So what happens is there are a lot of, so the typical use case for tracing is network centric request response programs, right? But there is actually a subset of cases where you want to use traces, but you can't use like existing libraries. For example, if you are using if you're a JavaScript developer or like a mobile developer, right? Very likely you haven't heard of traces, right? Like tracing is like a back-end engineer thing, and even among back-end engineers, it's like a niche thing. Most people know logs, most people know metrics, but very few people know, even among back-end engineers, know about tracing, right? The reason why, even though like tracing is this notion of like a graph of events, right? The reason it's like hard to use in like other contexts is what is called a Hollywood principle. So what a Hollywood principle is most of the browser frameworks and like your mobile frameworks follow the Hollywood principle. What it means is it says don't call us, we'll call you. So whenever you have an event loop, right, like in the browser, the event loop will call you. You can't call the event loop. So what happens is the event loop has like very strict definitions of like the objects it takes and things like that. But when you actually want to trace a request across these event loops, right, you want to pass a trace context through. And in Java frameworks, because you have like thread local storage and like they don't follow the Hollywood principle, it's kind of very easy to like pass that trace context across your application. But you have a mobile application or like a JavaScript application, you have to basically every function that's calling your event loop has to be prefixed with like a trace context. Like this also happens with Go routines, right? So it what happens is if you use a framework on top, the framework also has to like pass that trace context and move back. As a result, uh, one, it gets very annoying, and your code you have this code sprawl with like all these trace IDs everywhere and trace context everywhere, and you have to like basically every function that's like calling into this loop has to have that trace context. Is just very annoying very fast, right? So that's the first problem. The second problem is uh, when you have like workflow scope so let's say you want to process a request, right? You said, hey, like this thing happened in my request, then this thing happened, and then this thing happened, right? But so logically, if you have like a microservice and like things like that, it's very easy to see like how a request response happens. There are very clear boundaries between the work performed and the request. Excuse me. So but what happens is there are a lot of cases where the work performed and the request scope do not match, right? For example, let's say I have a simple JavaScript application, right? A JavaScript application gets a request, right? Puts it in some like it has an event loop, and you put the thing into the event loop, and then you take the thing out of the event loop, do a little bit of work, then put it back in the event loop, then take it back out of the event loop, right? Now, if you actually do Java like tracing, where putting things in the event loop and taking things out of the event loop and things like that, in Java, because like there is a process per thread model or like an event model, and things are like in the back end very well abstracted. Putting things in and putting things out, you create a span pretty much in whenever this like thread like transition happens, and there is like kind of well defined notion of work. But what happens in JavaScript is like if you take a CSS animation, right, you're basically probably moving a pixel to animate it in and out of the loop, right? You don't want to trace it. It'll just like kill the animation too, in addition to like producing like a ton of spans, right? So in those contexts, what you want is maybe you want to track the time it takes to render the animation, and you say at the start of the animation, you say start, and then at the end, you say done, right? In this case, the scope of the animation is not like the request response. There may be like multiple requests and responses in this scope, right? Or the other example is, let's say you're tracking Slack app startup, right? It's called client boot. Now, what happens in client boot is Slack app starts up and it does like a ton of calls to the backend, right? And some of these calls are part of like loading the app, and some of these are like some housekeeping requests, right? Now, to know the latency of the client boot, we only want to track the requests that actually are part of like the boot process and not like the housekeeping stuff, right? Even though those are requests. And we don't want to trace individual requests because an individual request does not matter. What matters is how much time it takes to do load the entire app, right? So this is where the workflow scope and transaction scope do not overlap, right? They are different, right? And in cases like these, if you use an existing tracing library, it's just very, your code gets very complex if you want to like track how much time it's taking and things like that. And then you have other places where you just can't even use like traces. Like if you have a shell script, right? If you have a Jenkins job and you think, oh, it's a graph, I want to trace it as a trace, right? No, you can't, because you can't trace in shell scripts. You can only do like Go language or something, right? So, and then if you have like things that happen outside the request context, right? Like let's say you're processing Kafka job, right? Like, and this Kafka job is like doing muxing and demuxing, right? It may be like different flows. And this may be workflow outside of your request, right? For whatever reason. Or things like server stop and stop events. You can't represent them as spans. So because they're not part of a request. So like all these cases, when you actually start thinking about like, okay, how do I trace these? You spend a lot of time like you're fighting with that like tracing library pretty much, right? So the simpler solution in cases like those, and this rigidity of the tracing libraries is actually what makes traces hard to produce. So they're hard to use. They are, even when you produce them, right? They're hard to use. They're hard to query. Let's say you can live with that. They're also hard to produce. So you have to like do like a design review cycle just to like produce traces as well, in addition to like writing your code, right? Which is like annoying and it's like slow, right? So the solution actually is, oh, sorry, I think I forgot to fix the slide, but we created a lower level API for our spans. Let me just quickly show you the lower level API. The lower level API is actually very simple. Instead of like a complex library, you would have like an API like this. It says create and report a span. And then the API has like trace ID, span ID, parent span ID, service name. You just give it like, it's just calling a function. It's like a log statement in your code, right? So in all the cases where you can't use a tracing library or using the tracing library is super hard, you can just use this low level API, right? To actually get traces and like get value out of the system, right? Yeah, can you see my slides now? Okay, great. Yeah, sorry that I should have pasted the API. I forgot. Anyway, uh, yeah, so we basically, what we solve with the SpanEvent format is these three problems: easy to consume, easy to produce, and a simpler format that is easy to understand, right? So the design is not so much like it can do the same things, but it's a simpler API or a simpler UI for the developer, right? Now, a span event is, as I said already, it's a simplified span format for representing a span, right? But it's actually a lower level thing than a span, because when you're producing an actual span in like Zipkin or Jaeger, the data types and things like that, the complexity that Zipkin and Jaeger have is actually needed to ensure data integrity, right? If I ask the developer to do it right every time, it's very hard. Like without that data integrity, your data will be meaningless, right? So what we actually do is, that's why a span event is actually a span reporting format for even Zipkin or Jaeger. So you can think of it as like an intermediate representation of a span. Like you have a span, and a span event is like an intermediate representation where something like a Zipkin open tracing library or something else is actually enforcing the data integrity on top of the span, right? You can produce it like raw. It's like you can write raw assembly instead of writing C, right? But you just have to be more careful, right? So it's like that. And we have a few goals, like it should support querying the raw span. Like these are the things I already talked about. It should be easy to produce. A span event doesn't have to be part of a trace. This is like a big thing. because as I said, right, like the data guarantees are loose, right? So you can only have one trace ID, like you can only have one span with like, it's like a trace with a single span, right? And then the other thing we have is we wanted to capture the full fidelity of the spans so that we can actually use the existing instrumentation to produce these span events, right? I already showed you the structure of this span event, and I already said like the difference between traces and spans, right? So in Zipkin world, you have traces and spans, right? In our world, you have causal graphs, which are like a lower level IR for traces again, and then you have span event, which is an IR for span, right? And a span is also a graph, just like a trace is a graph. But the difference in our model is you're thinking in terms of causal graphs. You're thinking, oh, like this execution looks like a graph, so I want to represent it as a graph. How do I do that in the most easy way? I write span events. If my application is more complex, what do? I use a higher level library, right? That's how we think about it. And if I have like this complex nested annotation things, what do? I have a span type and add a child span, right? If I have a span that is of zero duration, you can do that too. It's called a point span, right? If you have a span that is not part of a trace, you can have a one-off span, right? So just by thinking in these lower levels, you're kind of like not limited to the restrictions placed by those libraries, and you can think about graphs, and you can think about your application execution. You can think about like mentally, you think in terms of graphs too, right? You think in terms of graphs and trees, so you can actually naturally represent your what is in your head in this data structure, right? You can do that by writing like raw code, or you can do that with higher level instrumentation. That's basically the idea behind causal graphs. And we chose SQL as a query layer because it's widely used. A lot of people know how to use it. It's easy to get started. It can be verbose for complex queries, but you can get the job done. And then the other thing is SQL has like nice UI building tools where you can drag and drop UIs, and like you get nice autocomplete and things like that. So, and also SQL is supported by like a variety of backends. So we take our data and put it in 3 different backends, and you can query any of those with like a variant of SQL, right? So this is the reason we chose SQL for this. So I don't know if I'm going too fast or too slow. So like, do you have any questions, or should I go ahead?
I think we'll take question at end.
Okay, I think like for now, I think it's been a pretty nice
Yeah.
cadence for the whole thing. So as far as I'm concerned, so yeah, if the audience feels something, I think they can write it down, and if they want us to slow down at this point, or we
Or
can just
any burning questions if anybody has.
yeah.
Yeah. Any burning questions? Actually, that's a good way. Yeah. If you have like a question where like, okay, this does not make sense, let me know. Okay, I will
Okay.
go ahead
Yeah,
and
I
like
think we're good.
show what we did. So probably that will give you a little bit more clarity. Now it's so far it's like more theoretical, right?
Yeah.
So like just like previous like Pinterest company, here also we built a tracing pipeline. So we have applications in Hack, we have Java applications, we have Go applications. So what happens is we have an internal message routing thing called Neuron. So all our Hack applications produce like we have an open tracing like tracer in the Hack application, and we have the same thing in like a mobile application and like a desktop application. So all of them provides produce span events, and they directly write this to like Wallace or Neuron or internal bus, right? And if you have a Go application or a Java application, you can use the Zipkin library and the Jaeger library, and those will actually write to Wallace as a different endpoint for Zipkin and a different one for Jaeger. Both of these will write the report the spans in Zipkin format and Jaeger format to the reactor. We'll convert them to span events and write them to Wallace. Okay, and then Wallace in turn will write this data to Kafka, and then we have a consumer like from Neuron that basically sends it to our data warehouse, which is backed by Presto, and we have two real-time stores. We send it to a tracing, we send it to one vendor, and then we send it to internal Elasticsearch cluster today. Okay, so that is our like tracing infrastructure. And then we have this trace view. What this trace view does is basically it takes the data, and then it shows nice the traces as like a waterfall graph, right? As I showed before. This is one for chat or post message. Then on top of these traces, you can actually build heat maps and you can calculate percentiles and you can draw nice charts with this data by writing these queries, right? And you can also actually query this data in Presto, right? We had the data warehouse, right, which is Presto. You can actually write complex SQL queries with joins and then ask questions, right? So we also have that. So we built all of these things at Slack, right? I'm not going to go into pretty deep into those because these things are kind of like obvious, or rather, these are like standard solutions that you can just look up in the APIs of those products. So what we do today is tracing every API request. We trace every API request, 100% of it in dev and about 1 to 2% of it in prod, right? The reason we sample in prod is our volume is so high. For example, like I showed you a single trace for sending a single message, right? That's like a fifth of it or something. So there is like 80, like there are like 150 to 300, somewhere in 300 to 500 spans when you send a message, right? So that's a lot, right? And that if you don't sample, that data blows up a lot, right? So that's why we sample to the 1 to 2%. And tracing has like had a lot of positive impact at Slack. It has provided a lot of end-to-end visibility into how Slack works. Otherwise, we had to like get logs and metrics from like a lot of these systems and like to look at them together and like understand them. So that's one problem. The second, like that's the biggest win for us. The second thing is the SQL has allowed us to explore the tracing data in like its full extent, right? A lot of our questions are like much more complex than like can be answered using simple queries, and a lot of questions are also answered by complex queries. So tracing has provided us the ability to ask questions and then prioritize the performance fixes to know where they can go, right? And also the one unique thing we actually do at Slack that I don't know anyone else does it is we actually use traces to solve production issues. Like I don't know of any company that actually uses tracing to solve production issues, mostly because the kind of questions you're asking during a production triage are kind of hard to ask with the Zipkin or Jaeger UI. So even if you deployed it, you can't ask like, hey, show me all the things where the MySQL query is failing for this endpoint. You can't ask those questions like that, right? We can actually ask and answer those questions easily. We have also made some adjustments to our instrumentation and things like that, so it's easy to like formulate those queries as well. But overall, we actually use it for triaging production incidents, and we can actually ask more powerful questions using SQL, right? For example, if we have memcache, we can calculate the P99 memcache latencies for a specific customer, right? For a given endpoint and things like that, right? And today we use memcache spans to actually calculate the hotkeys for memcache, right? Slack also has this feature where you have one database in one region and another database in another region, right? So sometimes when the request is slow and the database is in a different region, like developers like might just say, oh, like the database in a different region is slow because of that, right? But from trace data, you can actually look at the latencies and see whether the latency for the overall request is actually because of the cross-region query or not, right? So when we launch this, you can use this data to like run those interesting queries, right? So next steps, there's a lot of things we are doing. Like we are doing advanced samplers. We are doing a lot of small things like building tools and advanced analytics on top of traces. We also want to like build like a powerful query language where you can, instead of like writing like these gigantic SQL queries that I showed before, you can actually write like a one line, like a short query that is like easy to read, right? And we also have like a lot of duplicate data between traces and metrics. So we want to also merge traces and metrics into like the same thing. That way we don't have two islands where you have traces and metrics, but sorry, traces and logs, but just one thing where you can actually use your traces as logs as well. And yeah, in conclusion, like if you're like taking something away, this would be like querying trace data as raw data is like an extremely powerful idea. SpanEvent, the format we did is like a very simplified format that is really generally applicable, and it's just span meta annotations. It's not. It's like an IR for a span. It's not exactly like as powerful as a span. So the data guarantees are not there. So it's up to the higher level instrumentation to do it. As I said before, SpanEvent actually is databaseable, so it's easy to query using SQL, and like you can actually ask powerful questions. We actually ask powerful questions from our SQL, and we build dashboards out of this data. And in our system stack trace, we actually model traces as causal graphs, and span events are queried via SQL, and we find it to be a very useful model. And yeah, thank you. Think in terms of causal graphs. So
Yeah, thanks so much, Suman. Like that was like really, really insightful. Uh, because like a lot of us, like Pranay and I have spoken about this. We have sort of also
Yeah.
worked together and spoken about how to sort of design UIs and represent trace data, even though it's like very rich and useful from a data perspective. How do you make it more useful? And Pranay, I think, has a lot of insight on this. He has been researching a lot on how to make this data look good, like, and
Yeah.
make it more useful.
So one thing we usually find is that all the tracing UIs which we see are like people always ask for more. Like there are lots more things they
yeah,
can ask and they can do. So this is very refreshing. Like what more can we do? So this really opens up like next level of things which we can do.
And Pranay,
Uh,
I think the word that you're looking for is clunky. Most trace UAs are clunky.
yeah.
Hey, Venkat's joining us. Cool. We
Hey,
have
hey,
a new
Venkat.
speaker. Hi,
hey,
Venkat. Hey, one question from my side, Suman. The
sure,
specific thing that you mentioned that you actually use trace data to solve production issues, right? How
yeah.
does that tie into your sampling rates? Because how does it guarantee the last few API
Yeah,
calls that you need actually got sampled, right?
yeah. So we have like a few things we do, and we don't do it uniformly yet, but there are a few things we can do, right? So first thing we do is if you have a reproducible. So first of all, we look for a trace, and at large, high enough volumes, we generally find like an error, even for like rare, like unless the event is super rare. For commonly occurring errors, we do sample something.
Okay.
Okay, so that's one thing, right? So normal sampling usually works. If it doesn't work for like the last 10 minutes, it usually works for the last day,
Right.
right? So that's one thing. The second thing we do is actually, if you have a reproducible issue, we have a way, like we have a secret command, excuse me, in our Slack client. So what you can do is you can actually run that secret command, and then you trace the next 5 minutes of all the requests 100%.
Right. Right.
So what happens then is if the customer has issue, we just tell them run it, and then we have traces for like that specific issue,
Right.
right?
Right.
And if the issue is reproducible by ourselves, we can actually run the command ourselves and like just do the thing, and then it'll work,
Yeah.
right?
That,
So
that, that makes
that's
a
the
lot of
second thing.
sense. Yeah, that makes a lot of
Yeah.
sense.
And the third thing we actually do in some places is so every time there is an error, right? We actually sample it for the next like n calls. So because the intuition is very simple, right? Every time there is an error, whether it's like a software or a person, they retry it,
Yeah.
right? So when you actually turn on sampling on an error for that endpoint, the next time the same action happens, hopefully you have a trace, right?
Yeah.
And the higher up you can pass that signal of an error, like the better it is for you,
So this is sort of
right?
feeding back user or client behavior into how you think about
Yeah,
consuming trace
yeah,
and even producing trace
exactly.
also, which is great. Yeah.
Yeah, yeah,
Sometimes it happens that like some errors like are not application specific. It could be caused by peripheral systems like the host, the code is running in the pod, the host, or let's say something that has happened afar from your tree's boundary of applications, right?
yeah,
Tertiary dependency that is causing back pressure, and then
yeah, yeah,
it messes up that single one call in your thing, and then nothing happens, and then you have this sudden spike of a bunch
yeah,
of 4x's or 5x's or something, and then nothing,
yeah,
right? And those are
yeah.
the most hardest to debug because they are not reproducible mostly. And
Exactly.
yeah.
Yeah, yeah. Exactly. But yeah, message contention usually happens over like short periods of time, right? So
Right.
generally you can catch it. So I
Right.
mean,
Yeah.
yeah,
This will, your
again,
strategy is going to cover, I think, like 99 point again. All
yeah, yeah, a
pipelines
large
of,
percent.
yeah, that
Yeah.
1,0,001% will remain, which is great. Like this is a very fresh way of thinking. Even the last couple of months, the way I have been thinking. This is a very fresh way. Cool. Thank you so much, Suman. We'll take questions
Oh,
from the audience right now. I think Pranay is handling the Slido. And a bit of apologies to the audience and also Suman to you is that I lost the audio during recording of the first few minutes. Unfortunately, Grafana Labs did not give us permission to record on this Zoom call, so I'll work it out with them next time. So I'm doing a screen recording for this time, and I lost first few introduction slide audio, but rest the main content is there. So sorry about that. We're
Uh,
slowly growing, we're slowly learning how to organize this better over time.
Suman, so we have a list of questions. I think we have 10, 12 questions. Do you
yeah, yeah,
want to
sure.
go through them or should I speak to you and then you will?
Actually, I don't know how to see the questions. How do I see them?
I just posted a link on the chat, Zoom chat. Can you see
Oh,
that?
okay. Uh, just a second.
Yeah. If you
Oh,
can
no,
open it here, that might be good.
no, wrong.
Go to Zoom.
Yeah.
Why don't you cast the screen, Pranay, and then
Okay,
Suman
yeah,
can
Yeah.
read it
Should
out
that would be
and
good.
I?
just
Yeah.
answer.
Should
That's
I?
that's the best
Yeah.
possible thing, right?
Okay.
Yeah.